We're very excited to show this powerful integration between MasterCAM and SpaceClaim today. My name is John Graham. I'm an application engineer with SpaceClaim. Also on the line with me is John Pratt, an application engineer with one of our rockstar MasterCAM resellers. They're a SpaceClaim MasterCAM reseller. So the way this works is I'm going to run through just a couple of slides, PowerPoint slides, to set the stage for you. John is going to walk through just the basics of the integration between the two softwares, and then I'm going to show you the power of SpaceClaim and where it really fits in. All right, so let's talk a little bit about SpaceClaim. What is it? Why was it invented? What is it all about? Well, if you ask me in one sentence what SpaceClaim is about, it's a smart 3D tool, next generation smart 3D tool for every engineer. It integrates extremely well in the manufacturing environment, and here's some characteristics about it. We have an extremely unique intuitive user interface. If you look down at the bottom of the screen, you'll see 4 tools: pull, move, fill, and combine. You'll see that in the user interface. You'll see me using those quite a bit. And this is what we've built the entire UI and the software around: simplicity, ease of use, getting your job done faster, getting parts out the door faster, because you don't have to spend a lot of time in the SpaceClaim environment. CAD neutral, what that means is we fit in the middle of all these different CAD systems out there, and because we employ this direct modeling paradigm, this technology, we're able to take any 3D geometry out there from other systems, bring it into the SpaceClaim environment, and do whatever you need. We solve geometry problems. So if you need to prep a model for manufacturing, simplify it, or create some kind of tool and fixture, repair a model, that's what we specialize in. That's what we do. And so we built this to speed up the manufacturing workflows, all those ones I just mentioned right there. And I'm going to show you a number of those in the demonstration today. We have an extremely low total cost of ownership. Think about it. Because it's such an easy software to learn and you're not spending days in a classroom, you can learn it on your own. We did a poll recently, and over 70% of our customers learn the software on their own by watching tutorials. So a lot of lower cost as a result of that, not just that, but the entry cost of purchasing the software too. So I talked a little about interoperability and what we call CAD neutral, or how we're CAD neutral. We also give you the ability to open up CATIA and JT files. Not just open those, you can open them and edit them, but also save out CATIA and JT files as well. Editing the 3D geometry in 2D cross-sections, that's something very unique that we do. No one else does the way we do it. You're looking at a model in a familiar 2D environment, and you get to modify the actual 3D data. But sometimes when you bring models in, they don't always come in clean, and you have to repair them. That's why we have a full suite, a tab of repair tools to solidify models, to tweak them afterwards, to modify different faces, to get tool paths correct. You'll see some of those things as I go along. A lot of workflow-specific tools, so sheet metal functionality, hole recognition, file repair I just talked on. So those are some of the benefits and the things that SpaceClaim allows you to do with geometry. The fact is, geometry is generally a bottleneck. And so we really try to remove as much of that bottleneck as we can. You can see some of the quotations on the screen from some of our happy customers that have seen the benefit firsthand of SpaceClaim and realized the time savings and the productivity gain because they're using SpaceClaim. All right, so one more slide to go through, just talking a little bit about the integration with MasterCAM. So you probably get the idea. It's a powerful geometry editor for all machinists. So SpaceClaim handles geometry problems. MasterCAM is an excellent tool for generating the code so as to cut models properly. So we open models from generally any CAD system. We'll fix dirty geometry. We'll make fixtures and tooling in a fraction of the time that you could do as compared to any other CAD system out there. It's an affordable, easy to learn software package, this next generation 3D modeler, and we're seeing people reducing their time spent in a geometry tool or a CAD tool by more than 50%. So there's some huge productivity gains to be gained from using SpaceClaim. All right, so I don't want to belabor slides. I want to jump right into the software. We've got a lot of great things to show you. What I'm going to start off with is first going straight into the MasterCAM environment. Now, John Pratt, one of our MasterCAM resellers, he's going to take over for just a minute and walk you through opening up a model and what happens in the MasterCAM environment. So, John, go on ahead.
Yeah, I need to have control, if you don't mind.
Oh, my fault. Let's do that right now. There you are.
Okay, thank you. Okay, I'm going to open up a file that is going to come in, and I know this file has some problems. The problems are the space is missing, and hold on. So the space is missing, and there's edges that are not watertight. And I just want to show you that. So we're going to take this model, transfer it out of MasterCam, and put it into SpaceClaim and do some repair work on it.
John, is this a model that you could work on right now in MasterCam? Is it something that you could just go machine?
Well, it would take me a lot of time to rebuild surfaces and to repair the edges that are not watertight. It would take me hours to repair this model. Just a few minutes here, I'm going to show you all the gaps and faces that are missing in the model. All these red lines that are right here, all those red lines, they're all gaps in the faces and edges, and you'll see there's a face missing right here. This face is missing right here, and all these red lines around here, they're all faces that are not actually watertight. They're not mated correctly. So I'm going to go ahead and export this out of MasterCam using a quick export button, export to SpaceClaim, and send it over to you, John, into SpaceClaim, and you can work with it.
Great.
So, go ahead.
Great. Thanks, John. Yeah, everyone, as you can see, there's a couple of buttons right up there in the MasterCam environment, and very simple, easy to understand. One button sends a model over to SpaceClaim, and the other will import whatever is in SpaceClaim directly back to MasterCam. So there's the models that John was just working with. You see it comes in as a surface body. It's not a solid as you would generally hope for, but when you run into that problem of having surfaces not solids, you use the slick tools in SpaceClaim to start to solidify a model up. You'll see as I go to stitch a model together, all those red lines that John was showing in MasterCam, they exist in SpaceClaim too. However, with our repair tools, with a click of a button, these automated tools will take all those edges and join them together. Now, I still don't have a solid body because there's other additional problems in the model, such as gaps or maybe missing faces. So SpaceClaim, again, the automated tool, SpaceClaim will find those and patch those over, heal them up. And so with just a click of a button, I was able to take what was bad geometry, missing faces, just jointed edges everywhere, and turn it into a solid just like that. Anytime you've got a solid on the screen in SpaceClaim, this is generally editable geometry. So there's different things I could do so as to make for, to help me with process planning and just different machining steps in the MasterCam environment. So what I'll do for starters is just dump that model into a component. It's sort of like a housing for it. And then make a duplicate right on top, just one additional solid that's the exact same as the one showing. Because maybe I want to have different solids to send back over to MasterCam that represent the different phases of machining. And all these pockets in the center that you see, I might want to get rid of those for the sole purpose of being able to just come through and machine off the bulk of the top face of this model, but I don't want all those pockets there. If you've ever used a traditional CAD tool before, you know that you oftentimes have a feature manager or some kind of tree to go over to so as to delete features. I don't have that in SpaceClaim because this was just an IGES file, it's dumb geometry. So that's why we have this third of our four major tools called Fill, which just takes geometry and deletes it. Any face or faces that I select, they get deleted when I use the Fill tool. And I'm double clicking to grab chains of faces, tangent faces. Very quick way to select things. I select what I want, I click the Fill tool, and things get deleted. The Pull tool, I'm going to talk about this one quite a bit, but this handles all of my editing and creation, disfiguring, disforming. I could grab things like rounds and resize those. So a lot of different things I can do, and I'm going to flush all those out with different models I'll show you in a minute. But going back over to MasterCam, let's see, I probably want to probably want to start a new document, just a blank document. If I'm in MasterCam and I use that import from SpaceClaim button, both of those solids that I had in the SpaceClaim environment now work their way right over to MasterCam. And I could create my tooling paths off either one of these solids and create the necessary process plans that I want. I like to change the colors of edges. There we go, so you can see it just a little bit better. And you can hide and show both of these solids and do whatever you want. So the point is, SpaceClaim is just an excellent, hands down the best pre-processor, if you will, for working with MasterCam. Take dirty geometry, make modifications to it, create tooling and fixturing, then send your model over to MasterCam when it's ready for tooling, or when it's ready for cutting. Now let's go back into SpaceClaim, because I want to, as I said before, flush out some of those concepts we talked about. I just showed you some of the basics right there of healing a model and making a simple modification to it. But let's take it further. I've got a bunch of files I want to run through. Typically when I show SpaceClaim, I'll stick with just 2 or 3 models, but this time I want to show a lot of models to you, because there's just so many great things to show in SpaceClaim, and it's fun to use different models to show it. Now here's a part that may not be too straightforward when it comes to machining. Because you have this frame, the part may be structurally a little bit delicate, and you may have to support it. A couple things I may want to do, these pockets on either side, those may be machined out at a different stage. Again, I could say, let's make a copy of the model so that I'm preserving, well, it looks like I accidentally pasted the one before, so that's okay. I'll do an undo, get right back where I was, and do a copy and paste operation. We call that 3D plagiarizing. Such a great way to reuse data, and gives you so much flexibility for how you handle a model. But it's those pockets, just as the pockets in the model before, I may want to get rid of. A double click selects them, and the fill operation just removes them like that. I could do the exact same thing on the bottom side as well. Now, the kind of changes you can make in SpaceClaim are really unprecedented. I mean, this came in as I believe a step file, and it may have been a CATIA file previously. But just because it's a CATIA file and I don't have a history tree doesn't mean I can't edit the model. I have full editing capabilities of this model because you're using our unique direct modeling tools in SpaceClaim. And so maybe your customer tells you to make this part, and there's some variations of it where the gap between the 2 legs varies. Well, you could go make those changes right here in SpaceClaim. When you're machining this, it might be necessary to put some kind of fixture between these 2 legs. After all, they're going to be a little bit delicate. They could break, so maybe you want some sort of a pin to hold them in place. You know, a very common thing you may have to do. SpaceClaim's a great tool for making that kind of geometry on the fly. I'm using, instead of like a pull tool in a sketch, just a dedicated cylinder tool, which just throws a cylinder somewhere in the model. Now, I obviously don't have precision on it quite yet. I'm roughing something out that's 1 1/4 diameter, but I want to cut a hole through the center of it. After all, this is just going to be a shaft that will, or a tube, if you will. It'll have a through hole. 3/4 of an inch, you know, that might be, the size of this might be something I could just buy off the shelf, okay? Now, I may decide to, I obviously need to take care of the interference problem. I could have made this the correct size right away, but I did this way because sometimes it's just easier to get something on the screen and then use the fast tools in SpaceClaim to just chop up a model however you want. I'm using a variation of this 4th tool called Combine. It stands for combination. It cuts bodies, but it also merges them. So I'm using it to slice this body along key locations. And so now the fit is much better. You know, the pin pretty much looks the way I want it. But, you know, to play it safe, you don't know if your model is perfect. That is, if the fit between your fixture and the model is exactly the way you want it, is just right. So we give you a tool called interference detection. With the interference detection, you can find out exactly where you have problems. I mean, that's something I couldn't really predict. It shows up in bright red where the 2 bodies interfere. And so now I know to go take care of something over there. So what I might do is, you know, I like to work in this cross-section environment. You saw me do it just a second ago. All the main tools in SpaceClaim, pull, move, fill, and combine, they work in a cross-section environment. So as I zoom in, you can see, you see the 2D view, you see, let me draw on the screen for a moment, right where the green starts to interfere with blue. That's my interference. How do you get rid of that? Well, you don't have to mess around with any complicated features. You just use the combine tool to start slicing material away. SpaceClaim is smart. It knows where to cut the models up. It even puts you in a mode of removing that common, or any body for that matter, but the common body is what I got rid of. Okay, so going back into a 3D mode, maybe I want a little bit of clearance between that small lip and the workpiece, so I could elect just to move that radius. That's actually a cylinder. Just move it a little bit, maybe 10 thousandths or 20 thousandths to make a little clearance, and I'm good to go. From here, maybe you decide to put some rounds on the edges. I can do that. SpaceClaim, no problem. It's all done with the pull tool. This is your primary creation and editing tool, and the default behavior when you grab edges is to put rounds on. For some people, you may want to get rid of rounds, and we'll talk about that in a minute, or you may want to insert rounds as I'm doing here. I don't even have to remember what that dimension was down below. I could just reference it within this pull tool so that I'm ensured to get the same diameter or the same radius on the rounds anywhere I put them. All right, so that's just a quick example to show how I could put a fixture somewhere and modify a model for whatever purpose I'm trying to do. Okay, so let's take a look at a model that's got some rounds on it. So this is a SpaceClaim document. It originally came in as something else, but I've just converted it ahead of time to a SpaceClaim document, and it's just not really important where a model comes from because it's geometry to us. We let you edit it with ease. Whoever designed this, some of the rounds on here, in theory may look good if you're going to cast this part, but for machining it, it might be way too difficult to get a ball mill down into these rounds and get them that small. But even with something that was already created in another CAD system, I have the ability to go in and edit the radius of those rounds. The ones on the outside, I'll change to 50 thousandths. This engineer spec'd these out to be 25 thousandths of a radius, but I may only be able to get a 1/4 inch ball mill through there, so that would leave about 1/8 of an inch radius. So what I really would want to do is select all those rounds and modify them to 1/8 of an inch. And so it may not look that ideal, it may look a little goofy, but that may be actually what you can machine. So the point is, you can go edit a model any way you want to, so that the model actually reflects what's going to get machined. If you needed to build some tooling and fixturing based on what the model actually is, you have that flexibility now to be able to edit the model. I mean, in some systems, if this were I'll just pick on something like ProE or SolidWorks. If you had those CAD systems and you had access to the tree, you could go edit the model. But what happens if it doesn't come in a format whose CAD system you own, or if it's a neutral file format, like an IGES step or a Parasolid? Then you don't have many options for how to treat the geometry and how to edit it. Now, and I'll talk just a little bit more about rounds in a moment, but I want to move on to talk a little bit about fixturing, and in the context of how it's easy to make a fixture right in a part. What do I mean by that? Well, let's look at a small model. This is something that would need to be machined out. It's about 1.25 inches wide, so it's very small. Making this out of a small piece of aluminum or whatever it is and fixturing it, sure, you could do that, but it might be a little bit time consuming. The method I want to show you of how to create a fixture in this just utilizes the geometry around, and it's actually called something like a dovetail machining. Those of you that are you're machinists every day, you're probably familiar with it. You've heard it in the least or seen it. Maybe you use it all the time. Well, I want to show you in SpaceClaim how you can actually create dovetails on a series of parts put together and create geometry around here so as to be able to snap off the part from the base, from the fixture itself that I'm creating. So all I'm doing is using the tools in SpaceClaim. We'll call this 1/4 of an inch tall. I'm using the tools in SpaceClaim, pull, move, fill, and combine, and some variations of them to chop up a model, to reuse the data around me, push and pull on faces to get it in the exact form I want. And you see how simple it is to do. I'm creating the base here. I want it to extend all the way to that end face, so that's simple to do. I can reference that. The one on the left-hand side, maybe I'll eyeball and just say that base looks wide enough, okay? One more split face operation I want to do because I want to take that bottom right face and extend that out, okay? Maybe we'll call it a 1/2 inch. And by the way, sometimes I like to do dynamic changes and not put a dimension in, but you can always put precision into your changes that you make in SpaceClaim. You saw me put in a 1/2 inch offset to that face. The last thing I might want to do is actually put the dovetail on. So this is some kind of a base, right? And the dovetail needs to go on the bottom. You know, if I had a dovetail on another model, I could copy and paste that in here and merge it all together. Or I'm just making it myself. I'm drawing the dovetail out. Dovetails have draft, obviously. How do you put draft on? Well, anytime you need to modify geometry, disfigure, disform it, you generally want to use that pull tool. The draft capabilities are all built right within. So just based on the way that you select things, the software knows what you're trying to do, and it automatically puts that draft on those faces. And you can see it. And I think a typical dovetail is 14 degrees, but you can always change the angle depending on what you're after. So that's one part. It probably makes sense if you have a lot of these to do, to put them all together, to stack them all up next to each other. I mean, this is an area where SpaceClaim really, really excels, and the data reuse is just really unprecedented. So using this move tool, I mean, let me back up. When you're in Windows and you move files, everybody understands that. But if you hold down the Control key and you move files, you make copies of them. And it's no different here. When I Control-click, I'm making copies of all instances of those solids. And all 5 of them are put together. They're separate right now. They're not connected. You can see the lines in between them. But hey, I just used the Combine tool and merge them together into one. Okay? So I've got 5 parts. When you're done machining these, those generally will snap right off. And the entire fixture, the entire part is held through some other kind of standard fixture off the shelf through these dovetails. So it's a great way to machine things out. The last thing I might want to do is send over to MasterCam the singular, or just the stock model from which this comes. There's 6 ways to create that. In SpaceClaim, you could do it the way I've been showing you, where I take edges, pull on things, or even create a sketch and pull that out to make a solid. I'm going to use a different method called, it's using a tool we have called an enclosure. And it builds a solid right around whatever solid it is I select. It builds a brand new solid. And I can select, I could dictate the offset, the clearance between the enclosure and the body that I have in front of me, namely those 5 parts all connected into one. So there's my enclosure. I mean, it's a fast way to get something of a block on the screen. Now, the only issue is that it is, in fact, an enclosure, and it does have a hollowed out core, which I don't want. I want to get rid of all those faces on the inside of this. I have a way to do that. I could select all of them using this Power Select tool. It grabs every inside face, and guess which tool I use to get rid of those? I fill them all in. And in a couple seconds, it wipes out all those faces, and I'm left with just a clean block. That block you send over to MasterCam, that could be your starting point. It's great because I left 10,000ths clearance on this. I could leave 15, 20, as much or as little as you want. So this is great because you eliminate air cutting. You know exactly where your tool needs to, how fast it needs to go to get right up to this part, and then when it needs to slow down to start cutting. So you're drastically eliminating waste. You can use things like crash detection. In MasterCam, you can take advantage of all those types of things because you can export solids, any kind of a solid from SpaceClaim into MasterCam now. Okay, so that's a good example to show how you can fixture something up and create solids that represent the block that you start from. All right, let's talk a little more about some repairs that you might need to do to a model. Here is step file. I think this is the right one. Nope. Bear with me a second. I already opened up that one. I need to open up the step file right below it called bad rounds. Here we go. Now this is a part of a, it's just a cutaway part of something that's larger. You look at it and you think, okay, there's a solid, there's rounds, everything looks good. What's the problem? Well, if I zoom in, on a couple of rounds over here, or this corner, you can probably see all the jagged edges of where those two come together. I have no idea why that happened in the translation from wherever this came from. I think it was CATIA to a step file. But the step file, this is the geometry that it brought in, and it's corrupt. That's going to be a problem when you go to machine this out. Your tool may try to follow the contour of those lines, slow you up. You get surfaces that just aren't clean. How do you heal those things up? Well, I always like to say, and it is so true, there's a half a dozen ways to do things in SpaceClaim. I could fill in all those rounds, delete them, and just reinsert them. Now, because this is a simple model here and there's not that many rounds coming together, I could get away with doing that. But what happens if you can't just get rid of rounds via selecting all of them, wiping them out, reinserting them? I may need to chop them up and get rid of the problem areas. If I can draw on the screen again, this is really my problem area, so I need to get rid of that. Also, the edges nearby, the other edges on the other side of that sphere, they don't come in as jagged as the one on the left, but they do come in very small, and I don't want that either. I mean, this should be just one nice smooth curve. All right, so I need to get rid of that problem area and replace it with something else. SpaceClaim gives you the perfect tool for doing that. Under the Prepare tab, there's a dedicated round removal tool. It removes rounds, but it also takes away chunks of rounds. Just sections that I dictate that I want to get rid of. And so all I'm doing is isolating the problem area right in the center, and that's what I want to get rid of. So I've gotten rid of it, and how do I replace everything? How do I put it all back? Well, it's all done with the pull tool, right? The default behavior is to make rounds. So now when I click on edges, using this up to option to reference existing ones, in a matter of seconds, I'm able to put that junction right back in there, that sphere in there, and look at my edges. They're all they're all connected together. It's one clean, smooth edge. Now you won't have any problems with your toolpath. So that's one way. It's just a different way to get rid of problem areas and replace them. Okay, I saved the best for last. I got one more model I want to show you. And I love this because I've got an extensive history of using different CAD tools and just dealing with bad geometry in so many different models, but I've never seen anything like this, how SpaceClaim can handle repairing a model. Let me give you the background. This started off as an IGES file, and one of our MasterCAM resellers, they gave this to me, and they saved it as a SolidWorks document, and they said, we can't do anything with this. It's a simple block. We need to turn it into a solid so we can machine it. But we can't do anything with it. There's problems with it. We can't figure it out. How do you do it? How can SpaceClaim handle it? So I took a look at the model. And of course, when I see a surface body, I immediately go over to the automated tools and try to stitch things together. I generally run in this order. And I showed you stitch and gaps and missing faces. I don't think I touched on gaps, but it's just a sliver opening. And the idea is the same as missing faces. SpaceClaim finds them, heals them up automatically. This found 6 missing faces. So I click the green check and heal as many of them as I can. It says at the bottom that only 2 of them were fixed, so 4 of them were not fixed. So I zoomed in to try to figure out why, and it turns out these aren't actually just pure missing faces. It's not the appropriate tool for healing these areas. If you look closely, let me get the mouse in a little bit better position, you can probably see there's a little bit of a shadow line. It doesn't show that well right now. This is actually corrupt data. It's common, very, very common with IGES files. You saw a little bit of it with the very first model we worked on. But it's not a pure missing face. It's just straight up corrupt data. And so the idea in SpaceClaim is that why try to repair corrupt data? Why try to heal that up in and of itself? The tool I want to show you, we call either the sphere trick or the bubblegum trick. Here's the idea. I take that corrupt area and I just cover it over. I just completely cover it with something so geometrically simple like a sphere. Now, that sphere is just sitting on top of the corrupt area. It still exists. You might be wondering, what on earth is he showing? How is this even relevant? Here's how it is. It's a 2-step process. The idea is if I could merge all that together, the block and all the spheres together, I have now gotten rid of the corrupt data and replaced them with a geometrically simple sphere. So I've taken care of half the problem. Those corrupt things aren't there anymore, and I have a solid body. But now the obvious question is, John, what do you do about these gigantic spheres? You can't just leave those sitting there and machine them. And you're right, I don't want them there. So what do I use to get rid of them? The fill tool. I get rid of them. And look at that. In a matter of seconds, I'm able to take something that was corrupt and leaves you scratching your head. And I'm able to take just a very different approach that no one is able to do. This is so unique how we handle corrupt data. And I'm able to turn it into a solid in seconds, something that is very much machinable. And I'll go over to MasterCam and just import that model in so you can see for yourself. There it is. Nice, clean, solid body. So that's what I have to show you. I ran you through a lot of examples, but just to recap, SpaceClaim is just an excellent add-on tool for MasterCam. We specialize in geometry problems. MasterCam is by far one of the greatest out there in cutting parts and generating your tool paths very quickly. You combine the two together, you have a complete solution for handling geometry and getting parts out the door quicker. We repair, modify, and build tooling and fixturing around models like no one else can, faster than what anyone else can do. And you realize just a lot of time savings when using SpaceClaim. Okay, so that's what I had to show you. Give myself a pat in the back. We kept that right around a half an hour, but I do want to open up the floor to some questions. I'm not sure if you guys can hear me. I just had a notice that said my audio connection was lost. Okay. So I want to open up the floor to questions. I'm going to try to answer as best I can. There's a lot of them coming in. If I can't answer them, we will certainly follow up with each and every one of you as we go along, or probably in a day or two to come. There's a question about STL files and reverse engineering. There's a couple things that we do with STL files. We are very much just a CAD or a geometry creation and editing tool. So we will take STL files, bring them into SpaceClaim, and its graphics information at that point. But we'll let you reference the points of an STL file, draw in curves, draw in lines, connect those together using the main tools that I showed you. And you're just sort of building or hanging geometry off mesh files. So you could call it mesh morphing, or not mesh morphing, but there's just a number of terms people use for it. But you're just building geometry based on a picture that you see in the screen. And so we do handle that. If you do have an STL file, you don't have to build every feature off the STL. You could just build the milestone ones. For example, if I go back to this bowl, if this were an STL file that someone created or someone gave me and I needed to build a fixture off it, I probably would not mess around much with the details of those two features. But I would probably recreate the bulk of the bowl, and that would be used as some kind of a soft jaw to hold that part in place, and then maybe just a large opening that I could create. And just looking at the STL file, I could easily visualize it and drop in features and faces as I need to. Okay. A couple questions about cost. That's always a good one. We'll follow up with you guys on that. Very, very affordable for what you get. I mean, there's a lot of value in using SpaceClaim. Let's see. Boy, a lot of questions coming in. Can MasterCam simulate or animate the machining process? That's going to be a question for John Pratt. I don't know if you're still on the line, if you'd like to tackle that one, if that's something MasterCam can do, if you want to answer that.
Yeah, I'm here. What exactly do you mean by can MasterCam simulate the machining process?
I'm not sure. That person doesn't have audio, but that's all the question says. Can MasterCam simulate / animate the machining process? So maybe what they mean is, can they watch the tool actually?
Oh yeah, we have, in MasterCam we have verify and also machine simulation. So the answer to that is yes, absolutely. But yeah, you can watch the tool on the screen cutting away.
I believe if you have, there's a question about purchasing the add-on. I believe if you have SpaceClaim and MasterCam, then that is available for you. I don't believe there's a charge for that. There's a question also about handling Pro-E assemblies. I should have mentioned this earlier. I neglected to. Here are all the file types that SpaceClaim opens up. You have a pretty good list of the major CAD players and their parts and assembly files. And then neutral file formats like ASYS, I'll call AutoCAD DWG and DXF neutral, IGES Step, Parasolid, but the major CAD players are up there. So we'll open those, let you visualize them, inquire, and make full edits as you need to. Okay, how does SpaceClaim handle point clouds? We generally don't, well, not generally, we do not open point cloud data, but it's really STL files that will open up. Someone asked about subtracting an STL from a solid body. Yes, you can do that. There's certain ways to handle it. We do have the ability to take an STL file and turn it into a solid body on imports. However, that's really reserved. That's a good thing to do if that STL file was at one time CAD data. If it's scanned data, that's a little bit different. There's other tools out there that will take STL and turn it into something that's a little bit cleaner rather than very noisy scanned data. But we take CAD data that was, or STL that was one-time CAD data, and we'll turn it right back into a CAD file. That's something that I don't know that anyone does that, and it's very useful to do. Okay, couple more questions. Question about saving off or fixing step in IGES files, and then how to get those files back into some other CAD system, such as Pro-E, CATIA, SolidWorks. So the file on the screen, if you pretend that that was dirty at one time, I made my modifications, I cleaned it up, and I want to save it out. We don't save, instead of saving to the native CAD systems, we'll save as the neutral file formats. The exception would be CATIA, but we save out to ASYS, AutoCAD, IGES, JT, Parasolid, step file. The reason is if I take NX Unigraphics, for example, the native kernel they run on is Parasolid. There's really no difference between if I were to give you a PRT file or an X_T or B. It's the same thing. The geometry is just the same. Either way, when we bring a model into SpaceClaim, we dump the history tree, so it's never there if we were to export it out. So with all these file formats here, you can easily go from one system to another, no matter if it's SolidWorks, Unigraphics, Pro-E, you name it. If you are interested in this integration, I would say definitely contact us or your MasterCam representative, and we can work with you on setting that up. Very simple to set up integration. Okay, a couple more questions. There are a couple of tools you can use to compare something that was an original model that comes in that was dirty and something that's something that you just cleaned up, to look at the deviation between the two. That would take me a little longer to go into that, but we're always adding tools to help with that as well. Okay, what else? Google SketchUp files. Can you import Google SketchUp files? Yes, we can. We import Google SketchUp files, clean them up because they're often highly faceted, and we'll save back out to SketchUp as well. I think I must have breezed right over that one when I was showing the save out, the files we can save out to. There it is, SketchUp. So we definitely open and save to SketchUp files. Okay. Can you offset a finished model to represent a rough operation? Yes, absolutely you can. I don't know if I have a good one. That's a very good question. I don't know if I have a great one to show at the moment. You know, in its simplest form, I'll just take this model and grab a couple of faces and offset those. When I pull on them, you see the model getting bigger. I would probably do a copy and paste so that I could preserve the original, and then on the second model I have, then I would do an offset of faces, 5, 10 thousandths, whatever stock you want to add to it. A chain of faces that's tangent, I could grab those, pull on those as well, and those are actually offsetting. It looks like they're just moving to the right, but they are in fact doing a normal offset. So adding stock, yeah, definitely you can do that in SpaceClaim. Great use of the tool as well. Okay, you guys are asking great questions, much more than I can, many more than I can answer and handle at the moment. Can you create in-process sketches with dimensions? Absolutely, we can. You can. I think maybe what that question is asking is, can you create a drawing of something that's in process and show the dimensions of it? Yeah, let me do that for a moment and show drawings and also slicing up a model. So I've got this model in front of you with 5 instances of the parts. I want to get rid of all those just for the sake of simplicity. And with just a couple of button clicks, I can slice the model up, and I'm back to just the singulated part. Drawings is very simple, 2 button clicks. And I'm in a drawing environment. We put the top, the right, and the front view in front of you. You can always add an isometric view, or things like cross-section views, detail views. Let's see if I put a cross-section through the one on the right. I can use the view on the left to dictate where that goes, where the cross-section goes. Dimensions, very easy to put in. You just click the edges or the faces that represent where you want your dimensions, and you have them. Very easy to do. So you would make a drawing of another solid that represents a step that's right in the middle of this, and you're good to go. So drawings are very simple to do. One thing I love to show about our drawings and how we handle them is that we always keep you in a 3D environment in drawings. You think you're looking at a 2D sheet, but it's always 3D data that you're working with. So even if you want to modify something at the drawing level, you can do it. You can go click on a face and pull on it, and it'll offset and get bigger and smaller. Same with holes. You can do all that right here in the drawing. And you don't have these long rebuild times. It's just that particular face or faces that's getting edited and is being updated in real time. So good question. Okay, let's take just a couple more questions. All right, can you create okay, creating planes. Let's stick with, I like sticking with this small part. Creating planes to sketch in, very easy. You don't have to put the plane in the right place the first time that you do. You stick some plane, you stick a plane somewhere in the model, anywhere, and then using the move tool, I could rotate it or move it to a position and put as many planes in anywhere that I want. If I want the plane to go through the axis of a hole, then I tell it to move right up to that axis, and that could be a sketch plane for me. There's another question about scaling a model. This is very, very important. It's all done with the pull tool. You pull on a model from a given point, and then it scales from that point. You can always dial in and say, I want it to be 100 or 25% bigger, I suppose that would be, or if you want to shrink it, you say 0.75 and it's smaller. You can also scale, I don't know how useful this would be for machinists, but just to show you it's there, you can scale a model strictly in one direction if you want. So you're really starting to morph the model and change, just change the fit of it. But again, I'm showing you this because it's just unprecedented what we can do with geometry and how easy it is for us to edit geometry and how fast it is Okay. A lot more good questions coming in. I don't have time to show all of them. I think I might call that our session. Again, a lot of good questions. It would take me too long to answer all these, but we will follow up with all of you guys. And yeah, I think we're going to call that the session out. I just thank you everybody for coming. This has been recorded, and we'll definitely send this out to you for viewing later. And thanks again. Have a great day. We appreciate it. Take care, everyone. Bye-bye.